question.
I don't know.
Let's
Good
do
question.
that, shall we?
So if I just drop the S word, super loud.
So if I just drop the F.
That won't be good.
Just.
Okay. Woo! This is so fun. Alright, so we're still factoring.
Yeah.
But now it's going to be like an equation format. So we're going to actually have to find the x-intercepts of the quadratic equation. So it's all coming together. Why we be graphing and now why we're factoring. So we have what is called the zero product property. Ooh. So basically, if you're given a product of factors, I'm going to say, then each factor is equal to 0. So that's in words, but basically if you have like x minus a times x minus b equals 0, you get that each part equal to 0. So you can have x minus a equals 0, or x minus b will be 0. Okay, because one of those pieces has to be 0 for it to multiply to actually be 0. So that's why we can actually do this. And that's why it's an or statement, not an and statement. It has to be one or the other. Or it could be both probably, but. So, still factoring, we're just going to finish it by doing zero product property. Fantastic, right?
Indeed.
Okay. So, first question. What are the roots of the equation x squared minus x minus 42 equals 0? Does anybody know what this lovely word means? Yeah. Kind of.
Is that times a or minus a?
Minus a. Roots is a fancy way of saying zeros. Zeros is a fancy way of saying x-intercepts. That's a fancy way of saying like the solutions of the quadratic. So there's always different ways of saying zeros or x-intercepts or solutions or roots. They're all interchangeable. They're still talking about basically what we're trying to solve for, the x value.
So basically it's unnecessarily complicated.
Yes. Unnecessarily complicated is a good way to describe it. Okay. But I have this quadratic equation. For every quadratic equation, we want to try and factor it first. We're going to learn other ways, but factoring is definitely the easiest. So, how do we factor this left side? Go for it.
Oh, factoring?
Yeah. Well, we're factoring it by solving it. Solving it by factoring.
So your b would be negative 42.
C is negative 42.
Oh, your b is 1.
Negative 1. Okay, so what two numbers multiply to negative 42, but add to negative 1. Don't all jump at once.
What for that one? 6 and 7.
Oh, so which one has to be negative?
7.
Okay. So then how would I write this in factored form?
X plus 6, x minus 7.
Okay, so this is what we did yesterday. We wrote it in factored form, then we're done. So now today, the one extra piece, since we're equal to 0, I could set each of these parts equal to 0, and then solve the separate equation. So how would I solve x plus 6 equals 0?
Subtract 6.
Subtract 6. So one root is negative 6.
And then you would add something to the other side.
And then the other solution is 7. So I could plug these back in to actually check my answer.
So honestly, it's literally just flipping it.
Yeah, kind of.
So is it
You should always set it equal to 0 and solve, because
Sometimes
later
it might
we'll
not
have
work out.
a more complicated parts
But
to it.
like simple enough like that.
Yes.
So basically it's just what we did yesterday with an extra step.
Yeah.
This is easy. I literally finished that assignment in like what?
Yeah. Yeah. So you can check it by plugging negative 6 back into that quadratic
Yeah.
and plugging in 7. If you want to check it on a quiz or your homework assignment, that's the way to go. Okay. So we want to solve this quadratic equation. Looks a little different. We want to find the x values that make this true. We could guess and check. Or we could solve it by factoring like we did before. Yeah, what's different about this one than the other one?
It's already
The
at
product
that.
is 18.
Yeah, so it's already like factored, but it's set equal to 18 instead of 0. For us to use the zero product property, it has to be 0. So that 18 is a problematic. So we're going to need to move that on over to the left side.
So subtract 15
Okay, so x plus 5, x plus 2, and then minus 18 equals 0. But now do I have a product? Okay. So now I don't have a product on the left side. I do have a product, but I have a difference as well. So I can't set each part equal to 0 now.
Is that when you distribute 18?
Well, I want to subtract it. So I need to distribute x plus 5 and x plus 2, combine like terms, and then refactor it.
Okay, x to the x, x to the 2.
So when we do all that, what do we
You
get?
have x squared plus 2x, 5x plus 10. Right?
And then we still have minus 18 carried down. So when I combine like terms,
You have x squared plus 7x minus 8.
equals 0.
Refactor.
Yay! So the c and the b value.
C.
That's the negative 8. So then my factors are
1 and 8.
yeah. So which one has to be negative? Okay. So then writing in a factored form, what does that look like?
Okay, so then once you get down to that point in that your C and B, you are good to go from there.
Right?
Still easy.
So set it equal to 0, solve each one for x.
Minus 8.
Bam, there's my solutions. I could check them if I wanted to. But we never want to.
Why do the extra?
Hmm.
Does it mean we never right?
Yeah, we're good math students. We are right all the time.
No, not all.
No, you
But you see, if we were here and we were wrong, you would tell us if we were wrong.
Maybe. Probably.
It's all psychological games.
Mm.
Playing.
It is. Okay, so here's some words that you gotta know what they are. Find the zeros of the function by rewriting the function in intercept form. Nice. Does anybody remember what intercept form looks like?
Why do you-
That's slope intercept form.
Well, close.
Yep. Intercept form for a quadratic.
Can we write that down?
Yeah.
Is that
Um,
doesn't it do with A, B, C?
That's general form, which is what
Y
this is
equals
right now.
A parentheses X minus P parentheses X minus Q.
Okay, so yeah, this is intercept form
what lesson was that?
for 2b. Okay, what we have it written in is called general form. So basically, I want to convert from general form to intercept form. So intercept form looks like it's a product of binomials, so basically we're factoring this to write it in intercept form. So how can I factor x squared plus 3x minus 28?
Oh, you mean your C and your B.
Which are?
Negative 28 for your C. 3.
Okay. So then my numbers. Yep.
Yeah.
Well, what are my options? Okay, 1 and 28 doesn't work.
4 and 7.
Yeah, 4 and 7 work. So then, which one has to be negative? Okay. So writing this in factored form looks like
Y equals x minus 4. X plus 7.
x plus 7. So there it is in intercept form. Okay.
Just looks like,
Yeah. Looks like intercept form.
and then your A would just be 1.
Right. So can I find the zeros of this? What is zeros actually represented in?
X.
X-intercepts. So what are the x-intercepts of this in intercept form? The other way? We gotta flip the sign for x-intercepts, so it's 4 and
Oh.
negative 7.
Oh.
Technically it's set equal to 0 and solve them again. So I would show that stuff, but I don't like to. Okay. Yeah, exactly. Alright, we have a story problem.
Oh, nice.
Yeah, she loves story problems. Awesome. Ready? Okay, so you have a rectangular vegetable garden in your backyard that measures 15 feet by 10 feet. Then double the area of the garden by adding the same distance x to the length and width of the garden. Find the value of x in the dimensions. So here's my original 15 by 10. That was nice. So they want to add the same amount to the length and width, so like I extend this way x feet, and I would extend this way x feet. So I have this new region. Okay. Magic. So what do I want the area of my new garden to be?
15 times 10.
Okay. Yeah, so the old one is 150, but I want to double it. So the area of the new is 300, and then feet squared. But I need to figure out the value of x by using 300. So what's the area of a rectangle since that's the shape I'm working with? Length times width. Can I write an expression for the length and the width of this thing? Right. So we want to add the two side lengths, so 15 plus x. The width would be the same thing, 10 plus x.
Oh, yeah, just, yeah.
And then the area we said was 300, the new one anyways. So now I need to solve this for x.
Distribution.
Yeah, so distribute it.
So, 150 plus 50
Mm-hmm.
plus x plus x.
Okay,
Combine those
combine like terms.
25x.
Okay, can I subtract 300 on both sides? So it's 0.
So, yeah.
Okay, so here's my new quadratic, and we can solve it by factoring.
Your C is
All right. So yeah, that will work. Okay.
times 3.
15 and 3. There we go. So needs to multiply to negative 150, right? So either it would be negative 15, positive 10, or positive 15 and negative 10. So